the point of optimization, and this is the whole reason we study this too. Okay? So everything else you probably have seen before. All right? You have seen how to find volume, surface area, how to do all of this. Okay? But the point of optimization point that is new for the grade 12. And yesterday we talked about optimization, and we said that if you have in a 2D scenario, right? If you have certain amount of fencing and you want to make a chicken coop, what do you want to make? What was the shape that we came up with that's the best for that scenario? A square, right? Why is it a square? Because the square is giving you what?
4 sides.
What does the square give you? The biggest area, right? Because in a scenario like this, if I know I have this much fencing, right? I want the biggest area. So, in this case, we were dealing with 2D shapes. A certain amount of fencing. So one thing is given to me, and I was looking for the best dimension. Now, I'm going to look at 3D shapes. But 3D shapes is no different than 2D shapes. If square is my best shape for a rectangular shape, because my best shape is the square, what do you think if I'm looking at a rectangular prism, what do you think would give me the best shape for a rectangular prism? Or the optimal shape for a rectangular prism? Huh? What would be the best, the optimal shape if we're talking about a rectangular prism? A cube. A cube would give me the optimal shape. If I have a rectangle, the square is going to give me the optimal shape. Because remember, a square is a type of rectangle. It's a perfect rectangle, right? If the square is the optimal shape for the 2D, guess what? A cube, which is made of all squares, is the optimal shape for a rectangular prism. Okay? Now, what does optimal mean in this case? The purpose of optimization is to always, what do you think? Maximize or minimize surface area? So I've heard of different things. Who thinks it's minimize? I heard someone say minimize. And why do you think it's minimize?
Because you're trying to find like the best area, like compact, I guess.
The best surface area is how much material I use to make my object, right? So the less material I use, the better it is, because then my cost is going to be reduced. If you're talking about business, right? If you're a businessman or a businesswoman and you want to reduce your cost, you want to reduce your material. Guess what? A cube minimizes your cost, minimizes your surface area, minimizes your material that you're going to use. Okay? So when we're optimizing, we are minimizing. So the optimization is to minimize the surface area and maximize the volume. Okay? So you want to use the minimum material possible, but have the maximum volume possible. So, good. So the question is going to either be find the dimension to minimize the surface area, or it's going to be find the dimension to maximize your volume. Now, in real life scenarios and in real situation, right, if you're trying to make a pizza box, right, and you want to optimize a pizza box, guess what? If you make the pizza box as a cube, it's probably not going to fit your pizza, number one, properly, right? But in real life, sometimes we have to be, cautious of the shape that I'm trying to fit in that box, right? I'm trying to fit a shoes in a box, and the box is a cube, right? It might not be the best scenario. Now, so when we're dealing with rectangular prism, the optimal dimensions will always be of a cube, right? Because it's a 3D shape. right? So it's made of squares. So it's a rectangular prism, it's a cube. Now let's look at the formula. So let's look at the surface area of a rectangular prism. Get your formula sheets out so you have them. If you don't have them, come grab one. You can share it with other people. All right? So in your formula sheet, we don't have the volume or the surface area of a cube, right? Correct? But we have that of a rectangular prism. And we know that the surface area of a rectangular prism is, what's the formula?
2. Which one? For the surface area? Or
Yeah, 2 length times width plus,
Length, width times height
yeah,
plus length times height.
yeah. So this is the formula for a surface area of a rectangular prism, right? But if I have a cube, right? All my sides are the same. So we're gonna call it S, right? All my sides are the same. That's what cube is. So my length, my width, and my height, they have the same letter, right? Which is S. So that's going to be 2 times S, which is S squared, plus S squared plus S squared, because my length, my width, and my height are all S's. They're all the same. They're all either 2 or 4 or 7 or 9, right? They're all the same value. Are we okay with that? All right. Now, if I want to simplify this, I have 2 times S squared plus S squared plus S squared is 3S squared, right? Which means I have 6S squared. So the surface area of a cube is 6S squared. Because I only have one dimension. I only have one measurement for all my sides. Does that make sense? So we said here the length, the width, and the height of a cube are all the same, right? Now, how about the volume of a rectangular prism? What's the volume of a rectangular prism? Length times width times height, right? Length times width times height. But in this case, my length, my width, and my height are all S's, right? So I have S times S times S, which is S cubed. So the volume of a cube is S cubed, right? So when it comes to optimization, I will be using optimization of rectangular prism. I will be using these formulas. It's probably, they will give you one. So what they will do, they will give you either a volume or a surface area, and they will ask you to find the dimension that will optimize the other one. So let's say if they give you the volume, right? They will ask you to find the dimension that will optimize the surface area. So you're going to have to solve for S, and that S will optimize the surface area. So let's look at an example. It makes sense when you're looking at an example. And this is your shoebox example, and we're going to make it into a cube. Who cares? So the volume of a shoebox is 5,000 centimeter cubed. Okay, so they give me the volume. They're asking me to calculate the optimal dimension, and here's your key word that you're looking for: optimal. Okay. If the question doesn't say optimal, then it's a regular question. Okay? But when it says optimal, then you're looking at optimization. So calculate the optimal dimensions. What does the word dimensions mean? Length, width, height, the side length. Side length. Dimension means side length. So calculate the optimal dimension of the prism. Okay? Since they give me the volume, that means I'm optimizing the surface area, okay? So when they give you this, that means you're optimizing the surface area given the volume. So if you remember yesterday, I gave you the perimeter and I asked you to find the optimal area. So I have to give you one thing, either the volume or the surface area. Okay? So because I've given you the volume, what formula do you have to start with? The volume formula, right? So I know that the volume is equal to S cubed because I know it's going to have to be a cube because I'm optimizing. I know that my volume is 5,000. And what I'm trying to find? S, which is my side length. Okay, how do I find S? Cube root it. Okay, so to solve for S, you're going to have to cube root. Okay, what's cube root of 5,000?
17.1.
17.1? Okay, what is the unit for that? Centimeter. So therefore, because we are in grade 12, we have to write a therefore statement, even if we're in lower grade, but now it's a mandatory, otherwise marks will be deducted. Therefore, the optimal dimension of the prism are 17.1 centimeter by 17.1 centimeter by 17.1 centimeter. When you are reporting your dimension, you're reporting it length by width by height. You'll see that on anything you buy, right? Anything you buy, they record the dimension as length times width times height. This is how they write it, okay? So when you read something, you read it as length, width, height. Okay? No, this is just the dimension. So that means this box, whatever the box that we have, right? This shoe box, the dimension of it is 17.1 by 17.1 by 17.1. Okay? Now I can add to this question. I can ask you, find your optimal surface area. Right? I can say, calculate your optimal surface area. What would you do to calculate your optimal surface area?
17.1 times the 6 times 7.1 squared.
So if I want to add to this question and I want to say, calculate optimal or maximum, right? Or minimum, sorry, surface area, right? You're going to take your surface area formula, which is 6s squared, and then you're going to replace s with 17.1 because that is my optimal dimension. And what is that going to give me? What does that give me?
1,754.46.
1,000?
1,754.
And then unit?
Centimeter squared.
And then you can say you're very close to it. Okay? So in this case, I was given the volume. I found my able to find the surface area. We okay with this? Any questions? So the surface area of a pizza box is 45,000 centimeter cubed. There is a mistake in this question. Where is it? What should it be? And why is that? Because it's a box?
Remember, the surface area.
Because it's the surface area. Okay, fix that. So the surface area of a pizza box is 45,000 centimeters squared. Find the dimension of the optimal pizza box. So where do I start? Surface area formula. I know it has to be a cube shape. Doesn't make any sense to me, but you know, this is the question. Imagine your pizza coming like this. Right? It's like a super. Yeah. So you know your surface area, which is 45,000. It's only centimeters. So what do I have to do here? Divide both by 6. What is that? Sorry.
7,500.
And then? Square root. And then? What do you get?
19.6.
What is it? Sorry, 19.6. That's 19.6 centimeters. Not big, no? Why do they think it's more than that? But
I got 86.
I don't know. I feel like this is not.
Yeah, listen to me.
86.6.
There you go, 86 points.
Yeah.
Centimeters,
Yeah.
not centimeters squared.
Nope. Because you're looking for dimension, and dimension is
Really good at
centimeters.
typing, we are.
So if we're gonna find the volume, we just plug the 86.6 on the S over 3.
Yeah, so I can add to this question and I can say, what is your maximum volume? Okay? Or find the maximum volume.
And then you just plug that in.
Yeah. Now I can go and skip a step here. Okay, I'll show you something. That's a, oh. So to find the maximum volume, you just have to use your S cube formula, and then you have to cube 86.6. And what are you gonna get? Huh? I have a calculator. Why am I waiting for you?
649,461.9.
Now, what am I missing in this question?
Therefore.
Yes. So remember to do your therefore statement. You didn't get that? It's probably because I used the whole number. Yeah. You got 461.649 for 6.2. I used the whole number, like the 86.6, blah, 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 blah. Okay, don't forget to write your therefore statement so you don't lose marks. Now, something that you guys have to be careful with is what if I right away jump into the question of the surface area of a pizza box is this. Find the maximum volume, right?
And
So I'm skipping that middle question. But you still have to do that middle step. Let me repeat the question. I tell you that the surface area of a pizza box is 45,000 centimeters squared. I don't ask you this. I ask you find the maximum volume. Right? But you guys have to do this step first to find the dimension, then you're going to have to find the volume. Right? Because you can't find the volume without the dimension. Does that make sense?
No, Miss, repeat that.
So,
That's not.
if I ask you if I give you the same question, so the surface area of a pizza box is this, and I say, find the maximum volume. To find the maximum volume, you need your optimal dimension. I didn't ask you the middle step, but you still have to do this step. You still have to find your optimal dimension to be able to do this. Okay? So the question could change, but you still have to do that finding the dimension. All right? So you're always looking for these special words that says maximum, minimum, optimal. Okay? Questions about this? All right. So we know that the cube is your best friend when it comes to optimization of rectangular prism. We're all good on that page? Now, as you know, we don't always, and just be happy that it's only two shapes that we're going to talk about, because there's a whole course in university about optimization.
full course.
It was the worst course that you could ever take. I still remember the suffering I had. I like optimization, but I didn't like when it came to optimizing weird things.
Optimize your type.
So
The exact sizes.
So the second shape that we're going to talk about is the cylinder. Okay? So we know when we're optimizing a rectangular prism, our shape is a cube. How about a cylinder? If we're optimizing a cylinder, what would be the optimal cylinder shape? So cylinder is a cylinder. It has two circles and a rectangle, which is the lateral surface area. But what makes this shape uses the minimal surface area or getting the maximum volume?
Trying to see how much in there. The maximum. Try to see how much in there. The maximum.
But the maximum volume.
Yeah.
Okay? So what shape or what form would give me that? So in order for me to get the maximum or the optimal shape for a cylinder, I have to make sure that my height is equal to my diameter. So the height is equal to the diameter. That will give me the best or the optimal cylinder shape. If you try to make your height higher than your diameter, that's not going to work. If you're trying to make your height shorter than the diameter, it's not going to give you the optimal shape. Okay? Still going to work, but it's not going to give you your optimal shape. So for the optimal shape, I have to make sure that my height is twice the radius. Okay? Now let's see how I can take that cylinder formula and make it into my optimal formula. Okay? Let's recall the surface area of a cylinder. What is it? 2 pi r squared plus 2 pi r h. Right? So both of them are 2, correct?
Yeah.
And then the volume is?
Pi r squared 8.
our optimal formulas. What do we know about the height? What should the height equal to?
Twice the radius.
Twice the radius, or the diameter. But because I don't want to use another letter, I'm going to stick with the radius. So I know that my height has to be twice the radius. So for me to make that optimal shape, I need to replace the height with how much I need it to be. So I need it to be twice the radius, right? So what I have to do in the formula, I replace the height with twice the radius. So now my only variable is radius, right? If you look at this formula, then my only variable is going to be r. I won't have h anymore. Okay, so let's see how that works. If I replace the height with 2r, I will end up with this, 2 pi r squared plus 2 pi r times 2r. Yes? Are we okay with that step? Okay, let's simplify this. This looks too ugly. So I have 2 pi r squared plus, how can I simplify this part? 4, because 2 times 2 is 4, pi, r times r is r squared. Can I simplify this even further? What can I do?
Like terms one?
They are like terms, right? Don't you see? They're pi r squared,
So
right?
it's 6 pi r squared.
Correct. Right? So 6 pi r squared is the surface area of your optimal cylinder shape. Now, do you have to come up with this formula every single time? No, because now you know it. Right? You know that your optimal surface area for a cylinder is 6 pi r squared. So I have to do the same thing for my volume. I'm replacing h with 2r. So that's going to be pi r squared times 2r, which gives me what?
Pi or pi squared.
2
Pi r squared.
pi r cubed. Why cubed?
And then we do a square and you add another r.
Because r squared times another r, that's r cubed. Right? Yeah. So that's the formula for the volume, optimal volume. So now, there's nothing different than what I've done with the cube or with the rectangular prism. Same idea. If they give me the volume,
Cube.
I start with the volume and I solve for my radius. If they give me the surface area, I start with the surface area, solve for my radius. Okay? So you see that both formulas only have radius as their variable. Cool. Let's do that. So the surface area of a can of soup is 154.6 centimeters squared. Find the optimal dimension of the can. I know that a can of soup is cylindrical shape, right? I'm hoping. Right? Can of soup should be a cylindrical shape. Okay? This is how you know that you're using a cylinder. Okay? Where do I start? 6 pi r squared. Where is my, so there is this word here, optimal dimension, is the key that's telling me that I'm looking at the optimal shape. Okay? So, surface area equals to 6 pi r squared. Now, question for you guys. If the question is asking you to find the dimensions of the can, not the optimal, can you use this formula? If the question is asking you find the dimensions of no optimal, can you use that formula? No, this is only for the optimal.
Would they use other words than optimal? Or would optimal?
Maximum or minimum. If they want like find the maximum volume or find the minimum surface area, this is optimal.
Okay.
Okay. So what do we want to do?
Divide by 6.
Divide by 6 pi. Make sure you do it on your calculator and then you're getting this answer.
Yep, 8.2.
And then you square root it.
Yeah. And that's going to be 2 point. So I found the radius of my cylinder. How about the height? Yes, because when you're reporting, it's like when you're reporting a cube, you need the length within height.
Oh, it's
Right.
2.
When you're looking at a cylinder, you always need to report your radius and your height. Okay? So it has a height of, what would be the height here? 2 r, right? Because the height of my cylinder should be twice my radius. 5.8. So therefore, the optimal dimensions of this can is for our radius of 2.9 centimeters and the height of 5.8 centimeters. What do you think I can add to this? If I want to add another part to this question, what would it be?
Find the volume.
Find what kind of volume? The optimal volume or the maximum volume, right? So I'll ask you to find the maximum volume, and then all what you have to do is plug in 2.9 in your formula here to find your maximum.
You still have the ultimate, the optimum dimension, can I write just the surface area of this can?
What is it?
So if the optimal dimension of this can, R, can I just write like the surface area of the can? That would be right.
So the optimal dimension of the can that has a surface area of this or this will be longer.